Okay, part 2 of 4.1 notes, angle side angle postulate. So if two angles and the included side of one triangle are congruent. So let's take a look at what that would look like. So angle side angle, the side is going to be between the angles this time. Now, although I am drawing my triangles oriented in the same direction for these notes, just keep in mind that your triangles are not always going to be oriented in the same direction just because they're congruent. I'm drawing them that way now just so that they are, it's easier to follow. And of course, I'm not actually measuring these to make sure that they're actually the same size. We're just going for approximate. Okay, A, B, C, D, E, F. All right, so side angle side. If I know that angle A is congruent to angle D, and side AB is congruent to side DE, and then angle B is congruent to angle E, I now have angle side angle, and I know those are congruent. So if, let's see, are we going to show up? Yes. All right, if two angles, and I'm going to abbreviate this for purpose of space, we're going to use symbols. If two angles and the included side are congruent, then in two triangles are congruent to the angles and included side of another triangle, the triangles are congruent. Okay, so in this example, we have angle A is congruent to angle D. Angle B is congruent to angle E. And AB, segment AB, is congruent to segment DE. And therefore, we know that triangle ABC is congruent to triangle DEF. Okay, so that's side angle. Now, we also can have angle side. So if you have two angles followed by a side, if we're going around the triangle, you also can know those are congruent. Always trust what the diagrams say in terms of being congruent rather than how they look. That is what this example shows. All right, so we have I, G, H, and L, K, J. So if I am looking for angle side, I would say angle, side. So I could say G is congruent to K, H is congruent to L, and LJ is congruent to HI. So then these triangles are congruent. And that's angle side angle postulate. So if two angles and a non-included side are of one triangle, all right, are congruent to two angles and a non-included side of another, then the triangles are congruent. Okay, what that means here is if angle H is congruent to angle L, angle G is congruent to angle K, and HI is congruent to segment LJ, then triangle GHI is congruent to triangle KLJ. Okay, one more theorem, and there's a lot in here, but we're just kind of packing it in, and we're going to go from here. So, hypotenuse leg theorem for right triangles, HLR. So, if you know that you have a right triangle, meaning you have found a right angle, and therefore you can say that something's a right triangle, and you have, you know that the hypotenuse and the leg of that right triangle are congruent, then you know that the two triangles are congruent. So, hypotenuse leg. One of the things, of course, this takes into account is that the definition of a right triangle is a triangle with a right angle in it, right? So go ahead and draw two congruent right triangles, and we will mark those figures. I want to remind you that one of the benefits that you have with video notes is that at some point, if you need a little bit more time to write down what I've said or to draw a figure, you can just pause the video and do that. So please feel free to take advantage of that. Some students even like to re-watch them if they just feel like they need to hear it again. All right, so here are our two right triangles. We've indicated that we have a right angles here, so that means we have right triangles. And if RS is congruent to XY and RY is congruent to XZ, then we have a two congruent triangles. So if triangle RST and triangle XYZ are right triangles, then, not then, and RS is congruent to XY and RT is congruent to XZ, then triangle RST is congruent to triangle XYZ. Okay, that takes care of our theorems for proving triangles congruent. There is no angle side theorem. Okay, just to be perfectly clear. That goes for SSA. That's the same thing. We will take a look with constructions at why that's true, or I encourage you to take some time to try to demonstrate any of these theorems with constructions that are true or not true. This one is not true. It is possible to draw two triangles that have congruent angles, one congruent angle and two sides where the angle is not included, and those two triangles are not congruent. Okay, I'm going to pause here and upload this video for you, and we'll go into part 3 examples.